is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds
Good morning.
like area.
Today we're going to talk about segment relationships in circles. The first one is the chord product theorem. The second one we're going to talk about is the secant product theorem. And the third one we're going to talk about is the secant tangent product theorem. So the first product theorem we're going to talk about is the chord product theorem. And the chord product theorem just states when you have two chords that intersect each other on a circle, that the product of each of these lengths are equal to each other. So 4 times 2 is equal to 8 times x. 4 times 2 is equal to 8 times x. So over here, 8 equals 8x. X is 1 centimeter. Eight times 1 is 8. 2 times 4 is 8. And I just want to point out a couple of things. The chords do need to intersect each other. If you have a chord over here and a chord over here, you cannot use the chord product theorem. The chords have to lie exactly on the circle and intersect, and then the product of each piece is equivalent. The second product theorem that we're going to address is the secant product theorem. Now, just to clarify the difference between a chord and a chord is a segment that runs through the circle that ends on the circumference of the circle. A secant is just like a chord, however, it extends outside of the circle. Now, a secant product theorem is when you have two secants passing through the circle that end at a common endpoint. When you take the product of the lengths of one of the secants and you multiply it by the external piece of that secant, that is equivalent to the second secant, the entire length of it, multiplied by the external piece. So over here, this external piece is 6 inches. The internal piece is x. On this segment, you have the external piece is 5 inches, and the internal piece is 16 inches. So the product of 6 plus x, which is the entire secant, multiplied by the external piece, is equal to 5 plus 16, which is the length of the entire secant, multiplied by the external piece. When you simplify this, you can find out that the length of x is 11.5. You can always go ahead and double check your answers. So over here, 6 plus 11.5 is 17.5 times the external piece should equal 21 times the external piece. And when you simplify that, you wind up with 105 does equal 105. The last product theorem we're going to talk about today is the secant tangent product theorem. Now remember some of the differences between a chord and a secant. A chord lies only on the circle, and a secant passes through the circle. A tangent passes along the circle and only touches the circle at one single point. So over here we have a secant and we have a tangent, and they join together at a common endpoint. And what the secant tangent product theorem states is if you have a secant and a tangent that joins together at a common endpoint, you can take the length of the whole secant, multiply it by the external piece of the secant, and that would be equivalent to the tangent squared. So over here, we have the entire length of the secant would be 2 plus x. The external piece of the secant is 2. And our tangent is 4. And you would square that. And you find out that x is 6. You can go ahead and plug it back in to double check your answers. The entire length of the secant is 8. The external piece is 2. And tangent squared would be 4 squared. Well, there you have it. 3 different product theorems: chord-chord, secant-secant, and secant-tangent product theorem, all to find some of the unknowns.